Dear audience, in this video I will talk about the design and the implementation of VM Translator. VM Translator is a program that could automatically translate virtual machine code to hack computer assembly instructions. Here is an example. You can say push constant 7 is translated to this bunch of hack assembly instructions, and push constant 8 add, and then finish up. So the content of this video is from chapter 7, the elements of computer systems. If you have any doubt, please read this chapter. So for the VM to hack translator, we will implement 9 arithmetic or logic commands, include add, sub, neg, equal, greater than, less than, and, or, and not. In addition, we will also implement 2 memory access commands that interact with the stack and 8 memory segments. 8 memory segments include a constant, static, local argument pointer, temp, this and that. The constant is 1 that is different from other 7 segments, because constant is not actually a memory segment on the random access memory. It is just the intermediate value. You can push it to the stack, but you cannot pop something back to the constant. So in this diagram, we can see the static is located here, start from 16 up to 255. Local is a function's local variable. It is it is on the stack and pointed by the register 1 local pointer. Argument is an argument for a function pointed by register 2 arc. It is also on the stack. Pointer include 2 elements, this and that. They are related to the class. There's a pointer and this and that. Temp are several registers we can use to store temporary value. So here is my design of the entire VM translator. First, we have a main function, which basically reads in the .vm file and also capture the returned value from the inner stuff and read the generated assembly code into a .asm file. Inside, we got a VM parser. It reads each individual line and break it into different parts. The first one, we may have a different type of VM command, such as this one, push constant 7. It has a operator, segment, and value. For constant, it is value, but for other memory segments, the third number is called offset. We also got a VM command like a go to label. This one only has two parts, operator and a label. And then for arithmetic and logic operator, it has an operator only. So that's what the VM parser does. Once the VM parser identify it is which kind of VM command it is. Push, go to, or AND. It is then call the corresponding function implemented in this ASM writer and generates the corresponding assembly code. So the parser will check how many arguments 1, 2, 3, 1 or 2 or 3 are there on one line of a VM command. So if there's only one argument, which means the only operator it goes this way. Yeah, this is the parser tree of the VM parser. The parse tree. Yeah. One argument. So it is possible of any of these 9 arithmetic or logic operator or the end command. So let's have a look. Let's assume we got this AND VM code that goes to here. It has only one operator goes here and find out AND. So it is this one. The ASM writer will write this piece of code to the ASM file. Similarly, for sub, neg, equal, greater than, less than, and or the not, and the very end loop, they will be written to the ASM file. So let's see if we have a go to command in the VM. So it is to go to. In this video, I will only cover the content in chapter 7. So those functions in red will be talked about in the next video in project 8. So let's skip this part. So what happens if we have this push constant 7? So argument number is 1, 2, 3. 3 arguments. Is the operator push? Yes. Push constant 7, push. Is this memory segment constant? Yes. So we take this piece of code and put it into the .asm file. So if this command is pop constant 7, what will happen? It will encounter the one error because we cannot pop to a constant. For other 7 memory segments, we got a push and a pop for each of them. So let's have a look of the detailed implementation. Here is our main function. The program start executes from here. The main function may take several arguments. So let's have a look how it works. Open in File Explorer. Okay, in this file, where is the executable VM translator compiled from my source code? In VS Code, you just run build task. It will compile everything in once. It may take several seconds. Yeah, once you see this build finished successfully, it means executable is generated. You can also use PowerShell to compile the source code. So let's see In this directory, we got a source file in CPP. So we do G++, all CPP source file in current directory, output to a executable. This time I can call it test.executable. Let's see what is missing. Yeah, you can see test.executable is generated. So let's work on the test. Anyway, VM translator.executable. It takes let's see where we have the VM source file in VM files. In subfolder VM files, there should be another subfolder stack tester. Inside this we have let's remove this alt and ESM generated. Delete. Okay. Yeah, just run this VM translator space relative path to the .vm stack tester.vm source code. Execute it. So output is read to this stack tester.asm. So this is a generated code based on the .vm file. Okay, to test if our implementation is correct, we can use a CPU emulator provided in the Nand2Tetris toolkit, and load there are two test scripts. The one without VME is for CPU emulator. The other one is for VM emulator. So let's select the first one. Full speed and right. Okay, the test script gives us 1,000 clock cycles, so it may take a bit of time to finish. Okay, end of script comparison ended successfully. It means our VM translator could generate expected result. However, as you can see in this .vm file, it only tests the constant segment. So in the future, we are supposed to write our own test script to test all functionality of our VM translator. Okay, first let's close this for now. So this piece of code also checks the parameter format when calling the executable program. So let's see what happens if I loaded a wrong file type. Let's see if I accidentally loaded this CMP file. What will happen? It will prompt error message. Runtime error main input file must be .vm. This is implemented here. So what if I want to save the output in a different directory or different name. You can do this dot slash. Let's have a look. Have a name. Active dot asm. Under this is a relative path under the same folder as the executable. Okay, relative active dot asm. So where is that? Let's go back to here. Active dot asm. Here it is. Just generated in 1 minute. Okay, let's delete this for now. So this one also checks if there's too many parameters. If I do this, it will prompt too many parameters and refuse to execute. Okay, that's a function of this usage guard. The source file is specified by the argument argv1 here. It's a file name of input file name. The arg0 is a relative path of current executable executable program. So it will be the this one, this thing, and then plus the executable name. Absolute path. Yeah. And the output file is specified here. If there's only two, the absolute path and the input, it will assume the output file is the same as the input file, and just replace .vm with .asm. Otherwise, it will use argv2 as a new output file name. Okay, here we got we open up file input file stream. So we can use this get line from input file stream to get one line. For example is here. Okay, not this one. VM files step test here. One line. This is one line of command, but here is also one line. It is one line of comment. So how is this comment handled will be talked later. Let's assume this line is read into read with that get line get line function. The result will put into this line string, and in this while loop, it will loop through the entire VM source code, one line by line, and until it hits the end of file EOF, the last line of file, it terminates. So for each line, each line is saved as a string and passed into this pass VM line function, which is a member of VMP. What is VMP? It is an instance of our VM parser. Remember that? VM parser. Let's see how this VM parser is implemented. It has only three functions: constructor, destructor, and a functional method, pass VM line, which takes one string type VM line and return another string. So what is this? Okay, here, first we define two regular expressions. The first one detects /r. /r means return, which is put this cursor back to the beginning of this one line, and /n next line fader. So it just basically detects enter. So space. This detects one or more space. In case of there are more than one space between two arguments like this, more than one space, it will be translated to only one space. Okay, let's remove this line fader and replace repeated spaces with one single space. Then we have a vector. Vector is a variable length array. You can assume it is that thing. String type, so which stores tokens. What is token? Token is just one argument. Push, constant, 7. They are all tokens. Push is a token, constant is a token, and 7 is a token. So here we use the string stream. First, convert this string to a string stream. Because string stream supports more handy functions than the default string. So just here read the stream, which is a VM line. VM line read from the file one line and break it. Use a space. So if there's any space, break this string into parts and store it into a token. For each token, then push it to the variable length vector. So tokens will be a variable length array, one after another. Each one stores argument. So we can use tokens.set to count how many arguments are there. So here is a case of one operator. So that's all possible operations, all possible functions. For token sets 2, that one will be covered in the next video. Token 3, push pop and function call. So let's pick one as example. So let's see push. What happens if push is called? Push is operator 3 arguments. So it is here. Push, VM push. When the first token 0, the first token is a push, then call this function. This function is implemented in ASMW. So what is ASMW? It is an instance of our ASM writer class. There are a whole bunch of functions, including our VM push function. So this function is called with segment and offset. Segment is constant, offset is 7. So the segment will be, let's see, it first checks the segment. What is a segment? Segment. Yeah, here checks what is a segment. Is that a constant? Because in C++, which cannot take a string, what I did here is to have a map. which see, it is defined here. I have a map. This map, this structure is talked in my previous video in project 6. So here I just omit the repeated explanation. It has two terms. The key is a string, and the value is a VM segment. So what is the VM segment? It is a enumerator, just a sequential number 0, 1 down to 7. But each of them I give them labels, constant, static, time down to that. So whenever I put a string into, look up a string into this map segment, it will return the corresponding label number. So let's go back to the switch. So segment. When the segment a string equals a constant is passed here, this map segment will return what? Will return this one, 0, 0. So this one, the execution goes to this case. The red stuff is just paste this assembly code and write it to the SS another string stream. Let's see, where is that? This red stuff is wrapped in a red function. Here it is. If inside this assembly command there are any label, it will directly if it this means not found any label, it put a /t, which is a tab first, then put the command to the stream ASM, then append with a line feeder. So let's see an example. Yeah, here's an example. The generated code. You can see when it is a label with a bracket inside, there's no indentation. Otherwise, for normal instructions, there will be indentations. That's a function of this block. And then after each command, it changes the line feeder. Let's see. After each command instruction, it feed into the next line. Okay, that's our red function. Go back to the push. After write all those assembly instructions, just break out this switch, and here append another line feeder. This is just for clear to see. There are one more lines, so I can identify this is one corresponding to one single line, one single VM line, which is this push constant 17. Yeah, in this case it is very clear. Okay, let's see how this one is returned. At the end of this writing lines, I just convert the string stream to a single big string, and return it to the caller. So who is the caller? It is inside the parser. The caller is here, VM push, and immediately in the same line it return to who? The caller of this parse VM line. which is the main function. It is here, and all those stuff is catched by this string WTOF, read to output file, and this WTOF is pushed into the file output stream. Remember, we opened up here the output file. On close of this file output, all buffered stuff are written to the .asm file, and the program is returned with 0, indicates it's a successful execution. Yeah, I think that's all. Yeah, one more thing. Here, at the end of an assembly code, we have to include that end loop. So let's have a look here. This one, because after our code piece, after that in the computer memory, there may be uninitialized stuff or other program. So we don't want to bother with those unknown hell. So we have a endless loop here, just prevent our program from running away. Okay. That else? Anything else? Okay. I think that's it. My today's video. Thank you. By the way, this note, PDF version of this note will be available under my video. Also, all those code will be published on my GitHub.